last week, Coach Deborah talked about insulin resistance and the connection with perimenopause and menopause, but no matter your age, you can be insulin resistant. Sadly, in the state of North America and all of the Western diet, there are so many children out there that are now pre-diabetic and insulin resistant or have full-blown diabetes. So it does not matter your age. Your lifestyle plays a really big role. And what I want to go into this week is like really understanding what insulin is. So I have a slideshow. Bear with me here as we go through it. All right, understanding insulin. So we have to understand what insulin is before we can get into insulin resistance. So what is insulin? It is a hormone that is produced by the pancreas, and its main role is to control blood sugar, but it has so many other functions than just that. It signals nutrient uptake, not just blood sugar, but other nutrients as well, to promote the growth of cells. It tells the body what to do with things like, yes, blood sugar, but also lactase and ketones. It tells blood vessels to expand, and insulin directly impacts the calories out part of the calories in, calories out equation when it comes to weight loss and weight gain. So there's this whole debate on social media about, is it insulin or is it calorie deficit? Like they go hand in hand. The better your insulin sensitivity, the more calories that you are going to burn. If you are more insulin resistant, that's actually going to lower your metabolic rate and going to make it harder to be in said deficit. So insulin regulates macronutrient metabolism, carbohydrates. So we have our carbs, our protein, and our fat. In the topic of carbohydrates, it stimulates glycogen production in the liver and the muscles. So, hey, I have some glucose for you. Please turn this into glycogen and store it. And we know when we increase our carbohydrates and our lean muscle increases, that is because of the increase in glycogen over the week. So, ladies, if your coach ever bumps your carbs and you're like, oh my God, the scale went up, probably an increase in glycogen within your muscles. It inhibits glycogen breakdown. So when we are consuming carbohydrates, it's like, okay, we don't need to break down the glycogen that we already have because we have carbohydrates in. Save this reserve for a later date when we potentially need it. It suppresses gluconeogenesis. So this is when your body can take other things within your body to make glucose. So it's like, no, we're good. You don't have to do that right now because we have enough. And it promotes glucose uptake from the muscle and fat via GLUT4, which is what Deb mentioned last week. Insulin also regulates fats. So blood lipids, when fats are broken down, they are broken down into lipids. It stimulates fatty acid synthesis in the liver and in adipose tissue, so your fat cells. It inhibits fat breakdown. It promotes triglyceride storage in fat tissue. So, hey, fat cells, I have more for you. Hold on to this, which makes those fat cells bigger. It enhances the uptake of circulatory fatty acids, and then it inhibits and prevents ketogenesis and the production of ketones. So when blood glucose is high, the body says, nope, you do not have to produce ketones right now. We have enough fuel and energy coming in through glucose. It also regulates proteins and amino acids. So it is important for muscle building as well because it says, hey, muscles, I have some amino acids for you and other tissues. You have to remember that every cell in our body relies on amino acids and proteins. So it's insulin's job to say, hello, I have these amino acids for you. And for those cells to be like, yes, thank you. We're going to take those so that we can grow. Super important for protein synthesis and building muscle. It also prevents protein breakdown. So that's what we want. We want to maintain our lean muscle mass. We want to build our lean muscle mass. Insulin also regulates that. Now, I asked ChatGPT to make a kind of spreadsheet thing of all of these. So I'm going to zoom in. So we start with the glucose, already talked about that. Hormones, so it decreases glucagon secretion. So glucagon is the thing that says, hey body, hey muscles, hey liver, that glycogen that you have stored, we need that right now. So it suppresses that system. It increases fat storage, decreases or slows down fat breakdown. From a mineral standpoint, it also allows potassium to get into cells and it increases phosphate, which are important for cell function. It increases blood vessel relaxation. So, nitric oxide is one of the things that is important for allowing oxygen to get into the cells, and it affects reproductive systems and our immune system. So, reproduction hormones, Deb covered that last week. Fat tissue, already talked about. It activates different cell pathways and it suppresses energy burning pathways. So it's not just blood sugar. Now, on the topic of blood sugar, so what's happening there? When we start to eat, when we smell a food, when we taste a food, when we start chewing, an anticipatory insulin response happens. So this is like the pre-absorptive before foods ever hit your stomach, that pancreas is making insulin saying food is coming in. And this is where previous debates about like chewing gum or drinking artificial sweeteners making you insulin resistant because it tastes sweet, but you're not getting those carbohydrates coming in. Science has slowly started to disprove that, but taste and chewing, everything here starts your insulin production. And then when the food starts to get digested in the stomach and the small intestine, it is broken down into the glucose, the amino acids, and the fatty acids that then get sent to all the other things. And insulin is responsible for taking that from the bloodstream and giving it to specific cells. Blood sugar specifically, when that blood sugar rises, your insulin is also going to increase there because insulin's main role is to not have blood sugar get too high. Okay, too high blood sugar, not good for our health. It allows the nutrients to move into the cells. And then if there is some left over, it's going to say, hey, liver, please store this. And this is going to be a reserve for when our blood sugar is low and we haven't eaten. We'll come back to you later. So this is what happens in a healthy adult. Deb last week used a lock and key analogy where insulin is the key that opens a lock. I've mentally found that the bouncer analogy just sat better with me. So, what is the bouncer analogy? In healthy, insulin sensitive people, this is what should happen. Insulin is the bouncer, knocks on the cell door and says, hey, muscle, I have some sugar for you. And muscle says, okay, yeah, let the sugar in. Thanks. And then the bouncer goes on his way. Now, muscle cells can also be any other cell in this analogy that listens to insulin to regulate it. Okay, this can be a brain cell, it can be a vascular cell. Go back to that big chart with all the things that listen to insulin. It can be any type of those cells. Now, the start of insulin resistance is when the bouncer knocks on the door and says, hey, muscle, I have some sugar for you. And that cell either ignores the bouncer or says, sorry, we're full. So insulin blood levels then increase. The pancreas produces more insulin. So now you have two bouncers that are knocking really aggressively saying, let this sugar in. And muscle says, okay, okay, I will take it in. Over time, you have three bouncers knocking on that cell door. Let this in. This needs to be important. We need to get our blood sugar down. Muscle ignores it. Insulin levels increase again. More bouncers are knocking really well or really, really loud. Let this sugar in. Now you have a whole bunch of them trying to do the exact same job that previously one bouncer could do. So your body is producing more insulin to get the same job done, and you have higher insulin levels in your blood. How does this connect to chronic disease? The majority of chronic disease and health complications can be rooted in insulin resistance. So, type 2 diabetes obviously is the thing where if you're pre-diabetic and insulin resistance, it will lead to that type 2 diabetes, which is reversible. Alzheimer's, sometimes referred to as type 3 diabetes. This is insulin resistance of the brain that is a chronic condition that unfortunately cannot be reversed once you have entered that stage. It contributes to fatty liver. It also contributes to heart disease. So when there is inflammation and vascular cell dysfunction, so remember, insulin also tells blood vessels to relax. When there is dysfunction in the endothelial cells, epithelials in the gut, endothelial is this like protective single-celled lining of your blood cells and your lymphatic vessels. So it's a really protective thing. If there is dysfunction there, you can get plaque buildup, and that's where heart disease can pop up. High blood pressure as well. Insulin resistance is often a key contributor. So if you are someone who has been told you have high blood pressure and your physician did not test you for insulin resistance, they didn't test your ApoB1, they didn't test ideally your fasting insulin, but I will get to that. Please request that from your physician because if you correct the insulin sensitivity, oftentimes the high blood pressure also goes away. Other chronic diseases, so PCOS, same thing, similar to high blood pressure, where if you correct the insulin resistance, often, not always, the PCOS symptoms go away. In men, erectile dysfunction can be a symptom of insulin resistant as well because the blood vessels are insulin resistant. Cancer. Oh, there's a typo in there, but cancer is another big one that if there's too much insulin, if you have all of those bouncers circulating, specific cancer tumors have more insulin receptors than regular tissue. So if you have a bunch of these insulin like cells or bouncers circulating around your body and everyone's saying no, 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 but the tumor has these high insulin receptors saying, heck yeah, we'll take it. We'll take the blood glucose, grow, 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 grow. That is where it becomes very dangerous. Another thing is insulin inhibits autophagy. So autophagy and fasting is the whole trend thing because metabolism, you do need a balance of buildup and breakdown. We can't constantly always be building and we can't constantly be breaking things down. There needs to be that balance within the body. Autophagy is the cell turnover where we are breaking things down. But if insulin is too high for too long, remember insulin is grow, 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 grow. If insulin is too high, there won't be that breakdown. And that's where a lot of these issues pop up. Now, there are two types of insulin resistance, and I learned this earlier this year, and I was like, this makes a lot of sense. So everyone knows of the chronic and slow insulin resistance, where it builds up over time and it takes longer to develop and it takes longer to go away. And we want to focus on increasing muscle mass and prioritizing fiber and just being mindful of the amount of carbohydrates that you're eating in a meal and eating it with fats and eating it with protein and fiber. But a lot of people don't know about acute or fast insulin resistance. So we have all very likely been insulin resistant at one point. It can come in hours. It can also disappear in hours. And the main contributors for these is going to be stress, lack of sleep, high cortisol, inflammation, and too much insulin. So all of these create too much insulin. And then you also have too much insulin, which is just this constant cycle. And if you are or if there's too much acute or fast insulin resistance, it starts to become chronic. And that is where it is developed into the long term. So I want to go into the acute stuff because these are the things that you have control over most days as a preventative aspect. So the first thing is high cortisol throughout the day. So we want cortisol to be high when we wake up, but then we want it to drop off pretty decently in the evening. That peak cortisol is what wakes us up in the morning. But if cortisol is too high for too long throughout the day, the body says, we don't know what's going on. We're stressed as fuck. There's probably a tiger chasing us. Like, who knows what's going on? But we need to be ready for fight or flight. So we are going to increase our blood sugar. We're going to take in as much energy as we can, which is then going to increase your insulin. So saying, hey, insulin, you need to do more of a job so we can get all of these cells more energy for this fight or flight. So stress will increase your cortisol. One night of poor sleep will increase your cortisol. And then if you were relying on too much caffeine to balance out your lack of sleep, that will also increase your cortisol. So what can you do here? Get quality sleep, be mindful of your caffeine intake, and really, really lean into stress management. The next one that contributes to short-term insulin resistance is inflammation or immune system activation. Again, that exact same thing. We don't know what's going on, but we need to be ready to fight these threats because there's something coming into the body, whether it's a virus, a food that you negatively react to, something like that, where your body needs more energy to tackle that threat. So what can cause this? Eating foods that are not right for you. Okay, this doesn't have to be processed garbage food. Yes, that can contribute, but if you're allergic to tomatoes, or if you're allergic to bananas, or if you love gluten and dairy, and sometimes you go out and say, I acknowledge that this is going to make me feel really unwell and bloated and puffy, but I accept the consequences, that will make you more insulin resistant for the following day or two because that inflammation has increased. Being sick will make you more insulin resistant. If you are someone with an autoimmune condition, if you have a flare up where your immune system is either attacking itself in some way, well, typically that's what it is, that is also going to demand more energy. We need more blood sugar. Hey, insulin, increase. Smoking, vaping, alcohol, toxins in the air and water. So there's only so much we can do in terms of environment. So really focus on what you are putting into your body, stress management, and sleep. If you are consistently eating inflammatory things, you are stuck ongoingly with increased insulin resistance. So, for example, if you are allergic to eggs unknowingly and you have eggs for breakfast every single day, that can lead to you being chronically insulin resistant because your body is constantly fighting some sort of inflammatory threat in there. Now, if we take away the inflammation, and that's the only trigger of it, the insulin resistance also goes away. So we often have ladies that come to Lady the FUp. We change their food quality, and then they can eat way more than what they did previously. See the talk that Deb and I did 2 weeks ago with Deb, Sherry, and Beth, where Beth came to me. She was super digestive stress. She was bloated. She was gassy all the time. We got rid of the foods that caused her inflammation, and I was able to take her carbohydrates from 180 when we started up to 475. She could not have handled those 475 grams of carbohydrates previously because she was insulin resistant due to the foods that she was consuming. But we got rid of those foods, boom, insulin sensitivity shot up. She's able to eat way, way more. So if you are someone that's like, oh, I can't lose weight, my metabolic rate sucks, have a look at what you're eating. Doesn't necessarily have to be a unhealthy processed food. Bananas, almonds, eggs, tomatoes, cucumber, like the list goes on and on for common healthy food allergies. So really pay attention to what you are eating. Gas, bloating, burping, all of those are signs that your body is saying there's something in here that's a threat that we don't like. Now, the third one for this acute insulin resistance is just having too much insulin. So it's a consequence and a cause of insulin resistance where it's kind of a cycle that repeats. Kind of think of it, you know, that like Stewie Family Guy where it's like mom, 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 mommy, mommy, mama. And like Lois just doesn't listen. So think of that where the mom is just like tuning out the insulin. That's like, hey, hey, hey. But the dad hears it right away because he's not home all the time. So the insulin resistance is the lowest, ignoring the mom, mom, mommy over and over and over. Um, if there is always insulin in the blood, then it's always going to be increasing. It takes about 3 to 4 hours for insulin to come down after it has cleared out all of the blood sugar, being like, okay, cool, we've done its job. Now we can kind of settle down. But if the cells are tired of insulin always, always, always being there, it's just not going to listen the same way. This isn't just for glucose as well. So it's not just the insulin to the muscle cell or the insulin to the fat cell. This is your blood vessels. This is your brain cells. And that's why we see those chronic diseases being connected with it. Yeah, so insulin takes 3 to 4 hours, waits for all the blood sugar to get out. If you are someone who is potentially insulin resistant, you may want to consider not snacking. Because if you are having carbs for breakfast, and then you're snacking on carbs in between, and then you're having lunch with carbs, and then you're having a snack before dinner with carbs, and then you're having dinner with carbs, and then you're having a pre-bed snack, insulin will never have time to come down until you're sleeping. And that still might not be enough time for the levels, which slowly keep going up and up and up and up and up and up with everything that you are eating to drop back down to where they need to be. And then you wake up in the morning and they go up and up and up and up and up, and then they don't drop back down. And then over time, your blood serum insulin increases to where it shouldn't be. And this is why ideally you want to get your fasting insulin levels tested, not just your blood sugar. Really hard in Canada, but it is possible. Oh, yes. And then this thing. So snacking is a concept invented by snack companies back in the 1950s, 60s, something like that, just for companies to make money. Before then, snacking was not a thing. There is a lot of other cultures out there that don't snack. They think snacking is weird. We had people from Europe come over and they were like, "What? You guys eat all the time?" And we're like, "This is just the culture." Okay, so transitioning a little bit to understanding fat. So we have visceral fat, and then we have our subcutaneous fat. Visceral fat is the stuff in between your organs. This is not the healthiest kind of fat. And then we also have our subcutaneous fat, which is the stuff that we can squish and pinch that is over our muscle, but under our skin. Now, two people can be the exact same body fat percentage, but they can have different levels of these types of fat. So someone might have more visceral fat, someone might have more subcutaneous fat, and the ratio is going to impact their health. Fat cells shrink and grow, shrink and grow. Okay. So when we're losing fat, we're not getting rid of fat cells. It's just those existing fat cells are shrinking. Fat cells don't really die off, and if they die off, they're replaced with a new one, but they don't go away. When we're losing body fat, we don't go from having 17 trillion fat cells down to like 7 trillion. That's not how it works. All of them just get smaller overall. And when we gain fat, typically it's our existing fat cells that are getting bigger. The one exception here is after a period of dieting or low energy availability. Photo shoot prep, 60-day challenge, competition prep, just really aggressive dieting because I feel like it, eating 1,200 calories to get ready for vacation, fasting for multiple days. The body wants to put on more body fat. So it is going to expand those cells, but it can also create new subcutaneous fat cells. So you can't get rid of fat cells, but you can produce more, especially after a period of extreme dieting. So you have to be very careful with your reverse diets. This is why we as coaches are here to help you. Now, one thing to remember is the size of your fat cell matters more than the amount of fat cells that you have. So a smaller fat cell is a healthier fat cell. A bigger fat cell is unhealthy and sicker. Okay, so we want our fat cells to be small. The number of fat cells does not impact your health nearly as much as the size of the fat cells that you have. So visceral fat, that's your intra-organ, this stuff here, it has less fat cells, but they are bigger. So bigger fat cells, unhealthy, sick cells. And this is why the visceral fat is the unhealthier of the two categories. Okay. Bigger fat cells are also going to be more insulin resistant because they cannot take in as much energy because they're nice and full and they're like, we can't take more. If we do, we're going to burst and we're going to die. Okay. Your subcutaneous fat has more cells in general, but they're smaller and they can expand to quite a degree. The good news for us as women is we have more fat cells in numbers compared to men. So that allows those fat cells to grow. And when more of them grow, they don't have to get as big. Now, this is a general statement about genetic risk um, for insulin resistance and how our fat is distributed. So, those that are at risk for higher visceral fat, larger fat cells, the more unhealthy kind, East Asian and Southeast Asian. And then Latino, and then African American and Caucasian races are the ones that have higher subcutaneous fat levels compared to visceral fat. Now, there are going to be genetic outliers. Okay. You can be East Asian and have higher subcutaneous fat. You can be Caucasian and have higher visceral fat genetically. This is just the general trends that science has found. Now, what tells a fat cell to grow? Insulin. Insulin tells cells to grow. But if the muscles, for example, are rejecting the blood glucose, muscles, bouncers are knocking on the door. Muscles, take this, take this, take this. Our blood glucose is too high. You need to take this. Nope. Okay, we're going to go to the next thing. Fat cells, I need you to grow. I need you to take this. And the fat cells will say, okay, cool, let's grow. Yeah, I will take that. But they will only do that to a specific point until the cell gets so big that if it took in any more, it could burst. And now your fat cells are also insulin resistant. So you have the muscle saying no, you have the insulin, or sorry, the fat cells saying no, you have your brain cells saying no. And this is where things can get very dangerous. Natural physiological insulin resistance can happen typically in two times. So, insulin again wants things to grow, puberty, and pregnancy as a woman. So, big periods of growth when we are growing in puberty and fully growing into everything, that is when insulin can increase naturally. And that's where you have to be a little bit careful with carbohydrate intake, but also with pregnancy. And this is where that possibility to develop gestational diabetes comes in because the body is pumping out insulin, saying, we need to grow this baby. These cells have to grow. But genetic risks can play into that as well as diet when you are pregnant. Transitioning to brain health and insulin resistance. So, your brain has a very high metabolic demand. If you've listened to any of the previous talks that I have done, I've talked about basal metabolic rate, which is how much calories your body burns at rest. Your brain takes up a large portion of that BMR. And your brain is going to run off of one of two fuel sources, glucose or ketones. So, ketones are the things that are made when carbohydrates are low. We don't have enough carbs. We have depleted all of our glycogen from our liver. We have depleted the majority of our glycogen from our muscles. Okay, now we are going to rely on ketones. So if you have the fat cells are insulin resistant, the brain cells are insulin resistant, the muscle cells are insulin resistant. When it comes to your brain and the bouncers are going, hey, brain cells, we have this glucose for you. And the brain cells are like, nah, we're not listening to you. The brain is going to detect that there is not enough fuel coming into it. And it's going to say, okay, we don't have enough fuel from glucose, so we have to switch over and start making those ketones. However, if your blood sugar is high, your body's going to say, no, we are not making those ketones because we have blood glucose. So ketone production is going to be very low, but the fuel coming in from the glucose into the cells in the brain is also low. And now the brain's like, well, shit, we don't have enough fuel coming in, so we are going to down regulate everything. And this is known as hypometabolism. Okay, so hypometabolism of the brain can contribute to brain fog. It can contribute to headaches, poor mood, poor memory, depression, and epilepsy. And then in the long term, this can also impact dementia and Alzheimer's. So this is so much more than blood sugar. This is your cognitive health and your mood and your energy and your ability to focus and remember things as well. Now, testing for insulin resistance. Um, Here in Canada, it's okay, we're going to test your HbA1c, which is your average blood sugar over a prolonged period of time, and we're going to test your fasting blood glucose. But that is not enough, and that can result in false negatives for insulin resistance. This is where we need to be testing for fasting insulin. However, there's a lot of labs, especially here in Canada, that they just aren't equipped for that. They can test a whole bunch of other things, but they can't test insulin because our government says insulin's not the marker that matters. Hopefully that will change over time. There's a lot of personalized blood tests that you can order that you pay for out of pocket that can get that tested. If you're in the States, you have so many options. You have Function, you have what is the other one that I've used? Inside Tracker. You can buy specific ones. I know here in Canada, Dynacare offers it. So if you are someone that has connections or benefits with Dynacare, that may be one that you can add on. But if you are suspicious of potentially being insulin resistant, yes, get your blood glucose checked, get your HbA1c checked, but really have a conversation with your physician and say, I would really like it tested. Is there anything that we can do to make that happen? Now, GLPs. Where do GLPs come into this? We have heard about them. They supposedly help with insulin resistance. What's going on there? So the first thing to understand is what is GLP-1? GLP-1 is glucagon-like peptide 1. It is a naturally occurring hormone that your body makes on its own. It's actually made in the small intestine. And this is the thing that tells our brain we're full. Don't worry about it. We don't need more food coming in. It will also slow gastric emptying, saying, okay, we have enough nutrients in here. We're going to digest them slowly. We're not going to send it into the small intestine too quickly. We're going to give it some time so that blood sugar doesn't spike and crash. It's more of a slow arc. That's one thing that GLP does. The we're full also helps quiet the food noise. So those that I have talked to that use GLP-1 receptor agonists, such as Ozempic, Wegovy, Manjaro, all of those are not GLP-1s. They are GLP-1 receptor agonists. So they're just medications that mimic what naturally GLP-1 does, but your body makes its own GLP. GLP-1s also, there's like mixed research here, but it may improve the muscle microvascular function. So this is like your muscle's ability to take in more of the blood sugar and better respond to the bouncer knocking on the cell's door saying, hey, take this in. Yes, sir, we will do that. Now, understanding GLP-1 glucagon-like peptide, what is glucagon? Glucagon is a hormone that is produced in the pancreas as well. So insulin's produced there, glucagon is produced there. And glucagon tells the liver to stop releasing glycogen to increase blood sugar. So when insulin is low, glucagon will come in saying, hey, muscle, hey, liver, we need you to release your glycogen to increase our blood sugar levels because we never want our blood sugar to be too high. We never want our blood sugar to be too low. We want it to be nice and balanced. That's the entire aspect of the body is just keep everything balanced. So if blood sugar is dropping too low, glucagon will come in and say, okay, we are going to help provide the blood sugar based off of the stores that we already have. Now, with GLP-1s, glucagon-like peptide means it replaces or kind of does the job of glucagon. Okay, so it's going to decrease the glucagon in or that's being released. It is also going to stimulate a little bit of insulin production within the pancreas, which will then further suppress glucagon secretion. So the pancreas is like, okay, we're putting out some insulin. We're going to keep glucagon lower. And this over time, with this glucagon suppression and the insulin increase, can reduce your blood sugar because it's going to delay that gastric emptying. So you're getting less of that blood sugar spike crash. You're getting more of a smooth arc. The insulin can actually do its job instead of panicking, being like, oh my God, we have so much blood sugar. Knock, 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 knock. It's like, here you go. Here's a little bit of blood sugar. Yes, we will take that. Here you go. Here's a little bit of blood sugar. Yes, I actually need that. I will take it. Instead of being like, no, 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 we're full. We don't have any availability to take this in. So it's going to lower your blood sugar over time. Now, the negative impacts of these GLP-1 receptor agonists, your medications, if you are not consuming sufficient protein, and if you are not resistance training, you will lose a large amount of your lean mass. So you will be in a calorie deficit because you are not hungry. But if you are not doing the things that you need to preserve your muscle mass, you will lose your muscle mass. So for example, if someone loses 10 pounds, a non-exercising group will lose 6 pounds of fat and 4 pounds of lean mass. So 40% of that weight loss is coming from lean mass. It also increases your risk of osteoporosis, breaking bones, fractures. Deb and I did a talk on osteoporosis a while ago now, but 1 in 3 hip fractures, you will die within the year of fracturing your hip. So we don't want this chain and that outcome to happen. Other issues, because it does slow that gastric emptying, you get things like pancreatitis. You get things like gastroparesis, where food is really, really slowly moving through your digestion, and then other digestive issues, chronic constipation, stomach cramps, bloating. I've seen quite a bit of it, but thankfully, a lot of the women that I've worked with that started with it have transitioned off and are now feeling good. If you were to come off the drug, it is very easy to gain that fat back if there is no lifestyle modifications that were put in place. It just quieted the food noise. You weren't hungry. You get rid of the GLP-1. You're now left with the natural GLP-1 that your body makes, and you get that food noise back. The hunger signals are back. You start to eat in a calorie surplus again. You blow back up. However, the fat's easy to put on. It is very hard to put that muscle back on. And if you are after age 60, even if you are resistance training, it's going to be way harder to put on that level of muscle compared to if you had preserved that muscle through the calorie deficit. This one also kind of shocked me. GLP-1 receptor, so like GLP-1 meds, have quite serious mental health issues. The risk of suicidal thought goes up by 100%, and the risk of depression triples with these medications. It could be there's like theories on it of, okay, food was your crutch for the emotions that you were suppressing, and now you're not hungry, so you have to feel those feelings. But mental health does not improve when you use GLP-1s. Even though your body weight may go down, you think your body image, when you look in the mirror, you're going to feel better. Might not be the case. So, controlling our natural GLP-1, not using any medications for it. There are things that we eat that is going to increase GLP-1, and there are going to be things that lower it. So, if we are eating lower carbohydrate diets, that will increase your GLP-1 response. So, you will have higher GLP-1 naturally produced where you feel fuller, you're satiated, your insulin or yeah, your blood sugar is not going to spike. Your insulin is able to deliver all the things to the cells, and the cells will accept it. They did a study where they had groups of people. Body weight doesn't matter. Some were obese, some were lean, and they had them try to eat just pure fat. Okay, same amount of calories, pure fat, and they saw whether you were lean or obese, the body had the same GLP production. So it all increased about the same. Now, for those that were obese, when they gave the same amount of calories of carbohydrates, they saw lower GLP-1 response compared to the leaner group. So those that had larger fat cells, because obesity is large fat cells, whether that's visceral or subcutaneous, they were the ones that were still hungry after just pure carbs compared to the lean group, got the same carbs, got the same calories, they had a higher GLP-1 response. So for those of you who are potentially insulin resistant, you may feel better on a higher fat, lower carbohydrate diet until you improve your insulin sensitivity. And this is sometimes where we as coaches, we naturally do this. We have you on lower carbohydrates for a while, and then we'll reverse diet you and bring your carbohydrates up. So we make sure the insulin sensitivity is present before we introduce more carbohydrates, which require insulin to be functioning the way that it should. And then the final slide here is how to make your own GLP-1, and that is fiber. Fiber is nature's Ozempic. When you are eating fiber, that is not a carbohydrate that is going to be converted into blood sugar. Okay, that is something that is going to go into your gut microbiome. It is going to feed, or your gut microbiome is going to feed on the fiber. And keep in mind, different gut microbiome species feed on different types of fiber. So this is where you don't just want to have psyllium husk, where you're like, okay, this is going to be my 25 grams of fiber. I'm going to have 3 capsules with every meal. You want to diversify your fiber. Different types of fiber feed different species of the gut microbiome. And when the gut microbiome feeds on it, it is going to release short chain fatty acids. And the short chain fatty acids are what stimulate in your small intestine your body to make its own and release that GLP-1 into your bloodstream. So increase your fiber. Oh, does anyone have any questions or feedback?
Just a reminder that it's the loss of estrogen that makes us less sensitive to insulin. So you can be extremely healthy, do everything right, as in eating properly, lots of protein, and higher amounts of fiber than, when you were younger, but you're still going to have this as a challenge. It's just the way we age. Doesn't mean that you're not ever going to get your middle nice and trim. I mean, I don't have a pot belly and I'm 60, but I have to work very hard at 60 to build muscle. I have to tell you, I get a little I get sharp with people when they say age is just a number. And if you're under 52, I'm going to give you a look because it is just a number in your mindset, but how you approach your fitness and your eating is very, very different. And I've noticed a difference in my own body in the last 5 years from 55 to 60. I need way more sleep. Cortisol affects me terribly if I'm stressed. My coach this week said to me, we need to bring down your cardio again just a little bit. And he's been really pulling back on the intensity, and I've been getting better results because he can't push me like he did when I was 52. Body's just like I can handle it physically and mentally, but the changes I want to happen in my body aren't going to happen. So, knowing that, if anybody has any questions, please feel free to reach out. And alcohol. Did you mention alcohol?
Very briefly, that was part of the like inflammation of acute slash short-term insulin resistance. Yeah, but
Yeah.
that was it. It was a very small point.
It suppresses um metabolic which metabolism is just the catch-all phrase for all chemical reactions in the body. We tend to think metabolism, oh, we're burning calories, we're getting leaner, but it's not. It's the catch-all phrase for all the chemical reactions, um, whether we're doing reproductive hormones or, our metabolic hormones, like our hunger hormones, insulin, glucagon, but it suppresses it in the younger female for almost 24 hours. For us ladies that are over 50, it can be long, it can take longer, it can take
Interesting.
days. So that glass of wine that you're thinking that, oh, it's going to relax me. Yes, it is. It's going to relax everything for the next 3 days and can undo your efforts of the gym that day. So there is science to back that up. So people who I did a really hard workout today and I'm feeling so good and I'm just going to relax with a glass of wine, it can blunt it. So yes, I know I'm once again the fun police,
What
but
you put into your body matters.
it really
Deb here,
does.
there's a question from Vinny. I think you addressed this last week, but happy to cover it again. Is it normal for fat redistribution to be concentrated in the abdomen after menopause?
That is where it goes after menopause because we no longer have the hormones to push it down to our button thighs. And where do we make our estrogen? Well, we make it in our adrenal glands after menopause. And where are our adrenal glands? On our back, like it's in our midsection. So the body is very efficient. Our bodies are so lazy. The less it has to do, the better. So if it can store fat where it can grab it nice and fast, it's going to. Why push it down to your butt and thighs? Those are reproductive areas. We don't need them anymore. We're not reproducing.
And in the abdomen as well, you have your subcutaneous fat, but you also have the visceral fat all around the organs. Remember, that is your bigger cells naturally that can get bigger.
Yes, but it's your subcutaneous fat that it wants for to make the hormone. So yes, great question, and it's very, very normal. And I don't know about anyone here that's, you know, past 40, but I think I noticed at 43, around 43 is like one day I looked and I was like, I have a roll on my back. Where did that come from? That's just normal. Like your body's things start to dwindle down. And so you have to change the way you eat. You have to change your lifestyle habits. You have to change the way you exercise. If you're a go, 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 go like this kind of person, you gotta chill. You can't be doing that if you want to get rid of the belly fat because you're raising your cortisol levels, which it's just like a revolving um carousel. See,
Yeah.
now my brain's not thinking.
Yeah. So when you are high cortisol, low sleep, high stress, all of that, that keeps you in that acute insulin resistance. But as the insulin resistance increases, it produces more insulin resistance, and then you shift into that chronic insulin resistance state, which takes significantly longer to overcome. But it is not impossible. We've had many, 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 many women improve their insulin sensitivity with us.
Oh, 100, and it starts with even just if you don't eat in the morning, start eating in the morning. A little bit of protein, some good healthy carbs, and get that fire burning. Fat burns in a carbohydrate flame, so you want to have a little bit of carbs, you want to have some fats, a little bit, and you want to have some protein. It can be as little as 15 grams of protein, but you don't want to go all night fasting and then continue it through, till midday.
Yeah.
That's actually one of the worst things that women, and even if you are insulin resistant, it's not that you want to be eating snacks and you don't want to be eating all day long, but eat, break that fast, use that energy to work out, to get your what you're doing for the next 3 hours, eat again with the idea of what you're going to do for the next 3 hours, then eat again. And then I do tell my clients, you know what? A 12-hour fast isn't a bad thing. But anything beyond 14, you're really setting yourself up for mismanaged blood sugar.
Yeah. And then when you think about all the people that aren't in LadyTheFUp, that follow a diet where they wake up and they have coffee for breakfast, spikes their cortisol, and then they have like a muffin or a bowl of cereal or something that not only is very high carbohydrate, low protein, low, and sometimes fats will be there, but like it's going to spike your blood sugar. It is going to cause inflammation. And then you fast for a really long time, and then you're starving by like 5, 6 p.m. because you had a coffee and muffin for breakfast. And then you come home and you eat all the easy carbohydrates, not prioritizing protein. So it's no wonder that, hold on, there's one more stat that I didn't put into the slideshow. Where was it? It's like 88% of American results have insulin resistance, which is insane.
Hmm.
Yeah. So, you ladies just being here, or if you have listened to this as a replay all the way to the end, you're on the right track. If you have any questions or concerns, you're more than welcome to bring them up with your coach. And we are happy to explain our reasoning as to where your macros are or where your nutrition is right now. Yeah. And if you have any concern whatsoever, do try your very best to get your fasting insulin levels tested.
And one last thing, if you didn't listen to my presentation last week and you are before these lovely years of perimenopause and menopause, women with PCOS, PCOS, polycystic ovarian syndrome, you are at a higher risk. And it's funny, my daughter has PCOS and is 15 weeks pregnant. And her OB, I was like, your OB this woman gets a gold star, said to her, "You're very tiny. You've barely put on any weight, but she's only 15 and a half weeks." She said, "But we need to really manage your blood sugar because of PCOS. So I'm going to be on you about that. And then we're going to be doing more fasting insulin testing." She goes, "We usually wait till 7 months, but I don't let my PCOS girls wait that long." So if you know anybody that has that you don't even have to be getting pregnant, but you just know that you have PCOS, that's something you want to, kind of stick in the back of your mind like, oh, I have a higher risk of that. So
Yeah.
you do not have to have belly fat. You do not have to be overweight. My daughter is like 5'6" and a stick, but she's
Yeah.
got PCOS.
It is entirely possible to be insulin resistant and be skinny fat, where
Oh,
you
yeah,
look at it and you're like, ah, you're fine. No, just because what you see on the outside, it doesn't necessarily match what's on the inside. Blood work is
exactly.
your best friend. Awesome.
I'm
Well,
done.
I appreciate all the kind comments, everyone. The replay will be shared later if you want to come back and revisit this, but I hope that you enjoy your evening. Thank you for spending time with us, and we will be back in November.